A very good morning to all. In today's video, we will deal with next topic of spherical mirror, that is all about convex mirror. Is that clear? So now let us have a quick review on the topic that we are going to deal today. So basically the very first topic is image formation by convex mirror, and then we will study the characteristics of the image that is formed. Then the concept of magnification or the definition of magnification and linear magnification. Then its relation with the distances and heights of object and image respectively. And then we will study a very short form or a summarized form of mirror formula and then the sign convention. So now let us start with convex mirror. Okay, the spelling is convex. Kindly just clear it. It is convex. It is also known as a diverging mirror. Why it is known as a diverging mirror? Because when a light rays fall on this, it is the reflecting surface. It diverges all the light rays. It diverges all the light rays such that when you extend it, it appears to meet each other at focus. Is that clear? Because it scatters or diverges the light ray away from the normal, therefore it is known as a diverging mirror. So this is the example why it is known as the diverging mirror. You can see that all the light rays which are parallel to the principal axis after striking the reflecting surface of a convex mirror is getting scattered, and when we are extending it behind the mirror, it is meeting at a focus. Therefore, it is known as a diverging mirror. So now let us start with the properties of the images that are formed by the convex mirror. Here we need to know the position of the object, then the position of the image formed, about its nature and the size. In a very first case, let us consider that in case of a convex mirror, let us place the object at any point, that is at infinite distance, the distance which we are not knowing. And we know that when the object is kept at infinite, the rays which are coming from the infinite source is always parallel to the principal axis. Now since it is parallel, so after reflection, it will pass through focus. This we have already learned in the rules related to the image formation. The very first rule was when the light ray is parallel to principal axis, after reflection, it either actually meet at focus or appears to meet at focus. Is that clear? So now the light rays is coming from the the source which is at infinite distance, and we can see that it is getting diverged, and when we are just extending it behind the mirror, it is meeting at focus. Now let's just look at the size. The size is highly diminished and it seems to like a point source, and since the image is formed behind the mirror, therefore it is virtual and erect. This was the first condition. Now the second position, when the object is at finite distance, the distance which we can measure and the distance which we know. So in this case, let us consider that the light ray is parallel to principal axis and is reflecting this one, the very first light ray which is coming and is getting diverged, and when we are extending, it is meeting at focus. The second one is again, this is parallel, or let us consider this is the light ray which is coming. This is the light ray which is coming and is getting parallel to principal axis. So these are the two cases which we have learned, and in that either we follow the second rule, or the other rule what we can have is, this is the light ray which is parallel, this got reflected, this we have extended. The other can be, it falls on focus and gets reflected, we can extend this and we can get the two light rays meeting each other between pole and focus. And if we compare the size of the image, we will see that the size of the image is smaller than that of the object. The height or the size is always taken with respect to the principal axis, and since the image is formed behind the mirror, therefore it is virtual and erect. Now let us start with magnification. What is magnification? Magnification just simply is the comparison of the size or the distances of the image with that of the object. In magnification, we come to know that how many times the image is magnified as compared to the object, or its size is magnified as compared to the size of the object. Therefore, it is defined as the ratio of the image distance to the object distance, and it is also defined as the height of the image to the height of the object. So, the size of the image and size of the object. We can see the object to this side and the images to this side. Just look at the size. The image is smaller than that of the object. Therefore, if we compare the size of the object to the size of the image, or the size of the image, sorry, not the size of the object, if we compare the size of the image in the numerator and the size of the object in the denominator, then we get the magnification. Similarly, we can just compare the height of the image to the height of the object as well. This is considered as the height of the image, this is considered as the height of the object, and the height is always taken with respect to the principal axis. So, the case in which the image is highly enlarged. Just look at this figure. In this case, this vertical up one is the object and the downward inverted one is the image. So now here the height of the image is greater than the height of the object. So m is equals to hi upon h naught, which is the ratio of height of the image to the height of the object. Now since hi is greater than h naught, therefore magnification will be greater than 1. Now the case in which we have diminished size image, that is hi is smaller than h naught, we have magnification less than 1. And the case in which both the image and height, both the image height and the object height is same as in case of concave mirror, we get magnification is equals to 1. So these are the different cases in comparing the height of the image to that of the object. Just keeping in mind that height of the image and the height of the object is never going to be 0, though when the light ray parallel to principal axis and is meeting at focus after reflection, but then also the image will be point source. It will be a point source, but it will not be 0. It will be 0 point something something something, but it is not going to be exactly 0. Magnification can also be written as m is equals to hi upon h naught, that is height of the image to the height of the object, which is equal to the minus of image distance upon the object distance, where v is the image distance and u is the object distance. So just you can always consider the object distance and the image distance, and keeping in mind that every distance is taken with P or a pole as a reference point. Now let us start with mirror formula. We have mirror formula as 1 upon f is equals to 1 upon v plus 1 upon u, where f is the focal length, v is the image distance and u is the object distance. Now, for solving any mirror formula, we need to learn the sign convention for the reflection of light by a spherical mirror. The very first rule that we need to learn is every distance, either the object distance or the image distance, is always taken from the pole. That is, if we want to draw 10 centimeter line, we have to place the 0 of the scale at P and then we will measure the 10 centimeter. If we want to draw object distance, we will just measure the distance to the point at which the object is placed, and we will measure the distance of the image from point P to the point at which the image is formed. The next rule that we need to learn is the distance which is measured always to the right of the mirror is taken as positive because it is towards the direction of the light, and the distance which is taken to the left, that is considered as negative distance. Similarly, you can just look at it, the distance parallel to principal axis, and if it is to the right side, Any distance which we measure to the right side is always positive. Any distance which we measure to the left side, that is negative. One more rule is all the distances which are measured above the principal axis, all the height which we consider above the principal axis, the height is considered to be positive. Therefore, an object is always placed above the principal axis. Therefore, the height of the object is always considered as positive. But the case in which the image is formed, if the image is formed below the principal axis and is inverted, the height will be considered negative. And if it is above the principal axis, as in case of virtual and erect, it will be positive. So now just we can look the distances below the principal axis which we are considering it as negative. Now the next about focal length. All the distances, as I said, all the distances towards the right is taken as positive. Therefore, focal length in case of convex mirror it will be positive, and in case of concave mirror the focal length will be negative. Is that clear? Hope these sign convention will help you to understand the topic and will help you to solve the numerical related to the mirror formula. Just try to learn the concept more by the content given in the book. Thank you.